Valence electrons comprise what percent of indium's total electrons? 6%, 14%, 36%, or half? Let's make sure we're clear on the definition of percent as an equation so we can adapt it for this context. The percent of something equals the total number of interest divided by the total amount in question. And we're going to multiply it by 100%. So if we adapt that for valence electrons, percent of valence electrons equals the number of valence electrons divided by the total number of electrons that the element or the atom has. And of course, we're going to multiply it by 100%. We look on the periodic table and we see that the atomic number is 49, and we have to make the assumption that we have a neutral atom because they didn't tell us otherwise. So the total electrons, which is our denominator, is 49. But what about the number of valence electrons, our numerator? So the outer electrons is tied to the group number. The group to which an element belongs is the same as the number of valence electrons it has. For example, all of the group 6 elements have exactly 6 valence electrons. Indium specifically belongs to group 3, so indium has 3 valence electrons. Now we have both our numerator and our denominator for our equation. We evaluate it, and we get 6%. So A is our answer. Let's take this to the next level. Phosphorus and fluorine. Which has a higher valence electron percentage? Or are they equal? We follow the same steps as before. We assume we have neutral atoms, so the total electrons equals the total atomic number. 15 for phosphorus, 9 for fluorine. And we figure out the numerator, the number of valence electrons, based on the group to which that element belongs. 5 for phosphorus, and 7 for fluorine. We get 5 over 15 times 100% for phosphorus, and 7 over 9 times 100% for fluorine. Evaluate it, and we get 33% for phosphorus, 77% for fluorine, so C is very clearly our answer, because fluorine has a much higher proportion of valence electrons, or percent of valence electrons, as compared to phosphorus.